Okay, ladies and gentlemen, welcome to our first virtual lab. And it actually works pretty well. So you're going to go to this link. It's going to open up this page, and you want to click on Adobe Flash. And it's going to ask you to allow once. Yes, please allow once. Okay, we want this guy right here. So let me change this a bit so that you can see what's going on here. Okay, so you can select all of your metals here. You can adjust your mass of your metal sample here. The initial temperature of your metal sample here, the mass of your water. Ooh, look at it go up here. And the initial temperature of your water here. And if you click on one of these, it tells you what metal it is and what its specific heat is. We're going to find the specific heat of unknown metal X and unknown metal Y. Okay? And the operative function here is that when you're doing this, the heat gained by the cooler substance is equal to the heat lost by the warmer substance. So that's how we're going to do this, okay? So what we're going to do is we're going to use our calorimeter, this is what this is, and we are going to calculate the heat gained by the water from the warmer substance. That's going to be our metal. And because we know the heat gained by the water, we know the heat lost by the sample. And you're going to use this equation to do it. This guy right here. Okay? So, if you know the heat gained by the water, and you know the, if you know the heat gained by the water, you know the mass of the water, you know the change in temperature of the water, and the specific heat. You can find, let me try that again. If you know the specific heat of the water, which you do, if you know the change in temperature of the water, which you can easily find, and the mass of the water, which you picked, you can calculate the heat gained by the water. If you know the heat gained by the water, you automatically know the heat lost by the metal. And if you know the mass of the metal, which you picked, and the delta T of the metal, which you calculated, you can find the specific heat. So, first thing you're going to do is open this link in Microsoft Edge. You got to enable Flash. And you're going to select metal X. You're going to increase its temperature to 220 degrees Celsius. Do not adjust its mass. It should remain at 20. Increase the mass of the water to 200, but don't change its temperature. We're going to let the metal do that. Once you have made these adjustments, click Start. You're going to record the final temperature of the water. You're going to repeat this twice and take the average. So you're going to record all that stuff here. Make sure you have the mass of your metal sample. Make sure that you have the mass of the water. And you're going to find the difference in the initial temperature and final temperature. And that's how you get the delta T. All right? Remember, if you know the mass of the water, the delta T of the water, and the specific heat, which you do, you can find the heat gained by the water. If you know the delta T of the metal sample, which you do, and you know the mass of the metal sample, and you know the heat lost by the sample, which you do, you can easily calculate its specific heat. All right? So I'm just going to ask you to calculate the specific heats for both metals X and Y. And here are some calculations to help you do that. Last thing I'm going to ask you to do is to perform the test on one of the known metals. You can pick any one of these that you want. I believe there are 3 or 4 of them to choose from: silver, gold, copper, iron. I tested this and it works great. I'm going to ask you to calculate the specific heat experimentally and compare it to the accepted value using percent error. Just have to do one of them, but I would like you to show me your calculations, and I want to see a value for percent error. Okay? That's all we're doing. Good luck, and you will have 2 sessions to work on this. So that's going to wrap up the week for us. Have a lovely spring break, and I will see you all next week. Excuse me, week after. Bye.